Hello everyone, in this video we are going to deep dive into the queue data structure in JavaScript. So first of all we will understand what is queue data structure, and then we will understand how to implement queue data structure using array, using linked list, and then we will solve few common asked interview questions on queue, and finally we will learn about the circular queue. So first of all, let's understand what is queue data structure. Queue data structure is same as the queue in real life, that is first in first out. For example, let's say you go to some market and you go to some grocery shop for buying some grocery. So in that line, if the person who come first will get the grocery first, and the person who join the late will get the grocery late. This is a simple concept. Let's say this is our queue. Right now the queue is empty. Now there are only two major operations. enQueue means adding an item in the queue. deQueue means removing the item from the queue. So in the queue, item will be added from the end of the list. So item will be added at the end, and the item will be deleted from the first. So let's say if you comes to any grocery shop, so who will be removed from the line? So the person who at the first will get the grocery or get their works done and remove from the line from the starting point. Okay. So this dequeue will remove the item from the end. And who will end enqueue? So person, if a new person wants to join that line, he or she will not join the line in between or at the starting point. He or she will be joined from the end of the list. That's clear. So let's understand with an example. So here, if I want to add 1 in my queue, so I will add from the end of the list. So 1 will be added here. Now if I want to add 2, so queue 2 will be added in this queue from the end. So this is my list starting. This is the front, and this is how it's starting. And now if I want to add 3, 3 will be added here. Then 4, this will be added here. Now if I want to dequeue, so this will be removed from here. Dequeue can't be possible from the 2, 3, 4. It will be possible from the starting only. I hope that makes clear. If that makes clear, so let's jump to the code and implement this with the help of array. Let's create a class queue, and in this class, first of all, let's create the constructor, and we are using the array method right now. So this dot queue is an empty array. Yep. Now we have to add enqueue here, which will take the data and add at the end of the list. Then we need a dequeue operation, dequeue, which will be deleted item from the starting. Then we need a front, which will return the first item of the queue. Also, I want to see what is at the back, last item. And then we need isEmpty, which will return is our queue is empty or not. So let's first of all create this isEmpty. So this very simple. This dot queue dot length equals to 0. This is a very simple. This is empty. Now let's implement the back. So we will say if it is empty, if your queue is empty, what will the back? It will return undefined, null, -1, whatever you want to say. So I want to say this dot is empty. If that's true, in that case you have to return null. Otherwise, you can return this dot queue at end. So at -1. So this will be at the end. Now, if you want to return the first item, so you will say this dot is empty, and if it is true, so return null. If it is empty, then return null. Otherwise, return this dot queue first item. So at 0. Now let's implement the enqueue and dequeue operation. In enqueue operation, what we have to do, we have to add the item at the end. For that, we will use our simple this dot we don't have to return anything. We will say this dot queue dot push operation. So what this push operations do? This is an array method which append the new elements to the end of the array. Okay. So let's end the data simply. And finally, in the dequeue, what we have to do? We have to delete the last item. So we will say, and we will return the last item which is deleted. Okay, this dot queue dot pop. So this will delete the last item and return that last item. Now, can you delete the item if it is empty? No. So what we will do? We will do here this dot is empty. If it is empty, in that case you can't return. You will say null. Okay. Otherwise, you will return the deleted item. So this is our enqueue operation, and let's try to see if that works or not. So const queue is equals to new queue. Now let's use queue.enqueue. That's the first operation. and I will add the 1. Now let's just console.log queue. So right now in the queue only 1 is there. Okay. Now let's add a few more items. That is 2, 3. So you see the item which is added first will be at the starting point, and this 2 will be at the end. The 3 will be at the end. I hope this makes clear. Now let's see if our dequeue operation is working fine or not. So if I do queue dot dequeue, so this will delete the third, that is the last item. Okay, is that makes clear? No, this is wrong. We don't have to delete from the end. We have to delete from the starting. So from deleting from the starting, we have to use shift operation. So this shift operation will delete from the, if I hover over this, you can read remove the first element. So this will remove the first element. So now if I save this code, so it will remove the first item. Okay. So now if I just copy paste, you can see first of all it's remove the first, then second, then third, and finally if I again do this, it will return null because array is empty. So now let's just go back. Now if I have deleted the first, what will my front element? So console.log queue.front. So it will return 2. So you can see also it is 2. Now if I want to check what is at the end, so I can say dot back and it will return 3. I hope this makes clear, and we can also check is our array empty or not. So is empty. So this will say false. This will say false. Now can we check the size also? Let's see. Can we see the size? Dot size kind of thing. It's undefined. And I check length. It is also undefined. So if we have to check the size, so we can create one more function dot size, and that will return the size. Return this dot queue dot length. So now if I just see queue dot size, so this is also working perfectly fine. So this is our queue implementation using an array. Now it's time to learn how to implement queue using linked list. But if you don't know about the linked list, I will suggest you to watch this video first and then come back to this video. Let's say this is our linked list and we want to implement queue using a linked list. So how to do that? So if you know, in the linked list we have a head which is pointing to the front of the list. Now if you want to delete, we know in the enQueue we have to add item at the end. So if you use a temp operator, that will just go through this and then finally add here the 4, that will take O of n. That will take O of n. If you use that method by first of all traversing till the end and then adding this, but the enQueue and dequeue operation should be O of 1. In the array implementation it is O of n, but we want here it should be O of 1. So how we will do? We will improvise our linked list using tail. So we will use a tail. This is another pointer which will pointing to the end item, the last item of the linked list. So now let's implement our enQueue operation. So let's say this is a tail which is pointing to our last item. If we want to do enQueue, so how it will do? It will simply first of all generate the item. Let's say generate the node 4. Now what we will do? First of all, this tail nest, this will point to 4. This is the first step. First step will be that tail nest will point to our new node. And the second step will be that tail will point to the last item. So this tail will point to this nest. Will this work? Perfectly fine. Now, here we have to see the nest is the dequeue. But before going to the dequeue, let's understand one more case here. One more case. Let's say if it is empty. So first of all, we have to create 1 and our head will point to this and our tail will also point to this. This is the case 1 when queue is empty. Case 2 if it is only a single node. So if it is a single node, our head is pointing to this and tail is pointing to this. Now we will generate a one more node, that is let's say 2. Now this 2 will be added at the end. So what we will do? First of all, make this, then we'll remove this and make this. Done. I hope you understand the enQueue operation. Now before explaining how dequeue operation work in the queue, first of all let's code this part only. Let's create a class queue linked list. This time I will say linked list, and this queue linked list will have the constructor, and in this constructor I have to set few values. The first thing will be this dot head, which will be initially points to null. This dot tail, that will also point to null. Then I need a this dot size, which will point to 0. Currently our queue is empty. Now what we will do? we have to write the enqueue operation, which will take the data, and from that data we have to do something.
Now we have to implement the deQueue, which will read the item and return the deleted item. Then we need again we need the front, which will return the first item. Then we need the back, which will return the back, and then we need the isEmpty, which will tell us like if our queue is empty or not.
Along with that, in the queue we need one more class, that is a class node, which will generate the node. So here we have the node and constructor, and this constructor will take the data, the value of the node. So we will do this dot data equals to data, and this dot next item, next will be null initially. So this is our two classes. Now what we have to do, first of all, before implementing the enqueue, let's implement the isEmpty. So that will be written this dot head. If our this dot head is null, that means it is empty. Okay, this is how we'll check. For second thing we can do is this dot size, this dot size equals to 0. We can do this also. Okay, second return, again we will do isEmpty. If it is empty, then you will return the null. Otherwise you will return what you will return, this dot tail dot data. Similarly, if we comes to front, it will say return this dot is empty, this dot is empty. If it is empty, so return null. अगर वो empty नहीं है, if it is not empty, in that case you will say this dot front dot data. How much simple is that? So helper function, we have created our helper function. Now let's use this helper function. So for enqueue, what we have to do, first of all we will create the new data, new node, using the new operator and the node class that we have created just now, and here I will pass the data. Okay, now what we have to do, in the first case, if this dot head pointing to null, if this is the case, that means this is your first node. So if it is your first node, you have to point your tail and the head to the new node. So what you will do, this dot head points to new node and this dot tail points to the new node. Yep, that's all. But if this is not the case, in that case what you have to do, first of all you have to do this dot tail dot next. That next is equals to new node. Okay, and then finally what you have to do, this dot tail equals to new node, we can say. So first of all you have to make let me show you here. Now finally you have to increase the size, this dot size plus plus, and here if you want you can return the size. If you want you can return the size, or if you want you can say return true, that this operation works perfectly fine. But for now let's don't do that. Here one more thing that you can optimize is that this dot tail is repetitive, so you can just put this line outside the if and else condition and you can remove it from here. So this is what you have to do. Now before going to deQueue, let's first of all find that if it is working or not. Okay, so create an instance q1 equals to new queue linked list, and now I will say q1 dot enqueue 5, and let me just console.log my q1 to find it's working fine or not. So here if you see, right now you have only one item. Let me just remove that also. So right now your head is null, your tail is null, size is 0. So if I add the first item, so your head will point to the 5, your tail will point to the 5, and the size is 1. That's clear. Now let's say if I add one more item here, 6. So now your head will be pointing to the first item, your tail will be pointing to the last item, that is 6. So head pointing to 5, tail pointing to 6, and size is 2. So let's add few more items here. So let's add 7, let's add 8. So head is pointing to 5 and your tail is pointing to the last item, which is 8. Now that's clear. So before just going to the deQueue, let's see if our other code is working perfectly fine or not. So if I do q1 dot front, so it should return undefined. So it is returning undefined. Why it's so? So let's see, this dot undefined. Okay, there is no front, it is head. That's why you should check everything. Okay, so this is returning 5. That's perfectly fine. Now if I ask what is my back, so it will return 8. 8 is back. Yes, that's also fine. If I just find what is the size of the queue, so say it's not a function, so let's just return the size. I will say size, or rather than size, if I just do size, then it's return the size. Okay, so I don't have to generate a class like a function for that. That's working perfectly fine. That's perfectly fine. So it's time to understand how to implement this dequeue operation. In dequeue operation, we just have to remove the first item from the list, and that's what we do in the linked list class also. So how you will delete it? Simply, you will remove this link and you will point this head to the next item. That's true. And one more thing that you can do is in the dequeue operation, that return the item which is deleted. Okay, and one more thing that you have to make sure that item is not empty. Okay, like the queue is not empty. So let's find out. Very first thing that we have to check is this dot is empty. If it is empty, then you can't delete anything. So you will simply say return null. Okay. Now, if it's not the case, you will say this dot head pointing to this dot head dot next, and that's what you have to do. Finally, say this dot size minus minus and return the last item. How you will return? For returning, you can just take the item const item or deleted item is equals to this dot head dot the data. So let me just return the deleted item and find out if that works perfectly fine or not, or is there anything that we have to do. So let's just call this here. Okay, console.log q1.dequeue. So if I delete, it's delete the first item, and the first item is 5. So it's delete perfectly fine. And let me just copy it one more time. It's delete 6, then 7, then 8. Now what will the next item? If I just do copy and paste, it return null. So it's working perfectly fine. So this is how we implement the queue data structure using array and using linked list. So now it's time to solve our next common interview asked problem: how to implement queue using stack. Lead code just changed their UI, so maybe this extension will not working right now, but no problem. But this is like commonly asked problem. So let's read the problem. Implement the first in first out queue using the 2 stack. Only 2 stack. So we have to use the 2 stack. The implemented queue should support all the function of the normal queue, that is the push, peek means the first element, and the pop and the empty. Push element back of the queue. Okay, push means you have to add at the back of the queue. Pop, remove the element from the front of the queue. Peek, return the element from the front. And the empty will return true if it is empty, return false if it is not empty. You have to see these notes as well, that you must only use standard operation of stack. You can't use any other thing. You just have to use standard operation of stack. To solve this question, you should have a solid understanding of stack and queue. So if you don't have the understanding of stack, I would recommend you to watch this video first and then come back to this video. So what these stacks do? Let's say in this stack we have 2 operators, that is a push and pop. And stack work on LIFO, last in first out. So let's say if this is my stack, I will add first. So let's say I will add 1. So this is at the end. Okay, then I will add 2. So I have added 2 at the last, but this 2 is at the top. Okay, and if I have to delete something, I will delete from here only. So I am deleting from the end, I am adding from the end. So deleting also from end and adding from also end. This is what stack it is. Okay, and what is queue? The queue works different. In the queue, you add from the end only. Okay, you add from the end, but it is removed from the starting point. It is removed from the starting point. So how you will solve the queue using stack? For that, we will use 2 stack. So let's say this is our stack 1 S1. This is our stack 2 S2. Okay, this is our stack 1. This is our stack 2. Now let's say first of all, the first operation is enQueue operation. You can say push operation. So if we, and this is assume this is queue. Okay, assume this is queue, but this S1 will work as a queue. This S1 here will work as a queue. So if I have to add 1, so what I will do? I will add 1 here. Simply. Okay. Now if I have to add 2. So if I add 2 here, what will happen? The order of queue will be changed. Order of queue will be, should be 1, 2, like this order. But if I add in this, so the order will be reversed. So what I will do? Before adding 2, I will remove 1. I will remove 1 and put 1 here. And then I will add 2 here. Now after adding 2, I will then remove 1 from here and add here. So now see the operation and the flow of stack and queue is same. So again, let's say if I want to add 3 here. So how I will add 3? I will remove all the item from this and put it in this stack. So first of all, remove 1, add it here, remove 2, add it here, and now I will add 3 here. Then again I will remove all the item from the S2 and put it here. So 2 remove comes here, 1 remove comes here. So if you see, this stack is in the same order of queue. So this is how your push operation works. Now let's say if you want to delete the top. So how you will delete? You have to delete this item 1. So this is at the top of the stack. You just do stacks.pop and it will be deleted. So here our push operation will take of n time, because you are removing all the item, putting in S2, then removing all the item from S2, you are putting this. So you are doing 2 of n, but I will say of n. Okay, and the pop operation will take of 1. You are simply deleting that. And the top operation, that is also known as peak. For that also it will take of 1. It will take of 1. Cool. So let's implement this. First of all, we will initialize 2 empty stack, that is this dot stack 1, that is empty, and this dot stacks 2, that is also empty. Now what we will do in the push operation, what we have to do, while our stack 1 is empty, what you have to do, you have to pop the stack 1 item, stack 1 dot item pop, and whatever item you are popping, you have to push all these items in the stacks2 dot push. Okay, so what you are doing, you are popping the item from the stack 1 and adding all those items in the stacks 2. Now what you will do, after transferring all the items from the stack 1 to the stacks 2, you will add your item in the stack 1, so that it will add it at the bottom of the stack. So this dot stack 1 dot push, and in this you will push the x. Okay, and finally what you will do, after pushing S1 item in the S1, you will place all the item from the S2 to the S1 again. So while your this dot stacks 2, so what you have to do, this 2 dot stack 1 dot push whatever your item removing from the stacks 2. Okay, so now this is how your push operation works. For the pop operation, this will work perfectly fine. You have to remove the element from the front of the queue. But before that, I have to implement this dot empty. So return this dot empty. So for that, what I can say this dot stack 1 dot length. If it is equals to 0, then it is empty. And what is the peak element? So peak element, I will say this dot is empty. If it is empty, then you have to return the null. Otherwise, you have to return the this dot stack at -1. Now how to delete it? For deleting, you will say if this dot empty. If it is empty, then you can't delete it. You will just simply return the null. And now otherwise, what you will do, you will say this dot stack 1 dot pop. And do I have to return the item? Remove the element from the front of the queue and return it. And you have to return this. Let's just try to run this code and see. I hope there is no error. So there is some error. So say stack 1. Okay, this should be stack 1. And let me just run it and just check out what's the output. Okay, so it's working perfectly fine. So let me just submit it. I think it should work. Okay, so it's working perfectly fine. Now let's try to solve our next question, that is circular queue. Why do we need a circular queue? So let's say this is our queue. Let's say this is my queue. Inside that queue, we have few items. 1, 2, 3, 4, 5. And here it is my head, it is my tail. Now, how I will add the next item? I can't add it because this is its capacity. Okay. So let's say in this queue only 5 item will be added. Now let's say this 1 item is removed and this 2 item will be removed. Can I add the item now? No. The reason behind that, we add the item at the end. But right now at the end we don't have any extra space. We have this space at the beginning, but in the queue we delete from the start, but we add from the end. So here you can see we have this space, but we can't utilize this space. So we can say our space is getting waste. So what we can do? So rather than using a simple queue, we will use a circular queue. In this circular queue, our tail is pointing to the head. So now if 5 is there. If there is some space at the beginning, so the next item will be at here. And now the tail will point to this. Now if I have to, and this head is pointing to this, okay. Now if I have to add more item, I can add it here. If I have to add more item, now I can't add. If there is an space, then I can add. If there is no space, then I can't add. But in the queue, if there is space, then also I can't add. Okay, so I hope you understand the circular queue. So we can again solve the circular queue using an array, using a linked list. But I think you can use the array method, and today I will solve the circular queue using linked list. That is a little bit difficult. Array part is very simple. You can solve it if you have already implemented the queue. Okay. Now let's go and solve it. So here is the question: design circular queue. Design your implementation of a circular queue. The circular queue is a linear data structure in which operation are performed based on first in first out, and the last position is connected to back of the first position. That is making a circle. So it is simple. The queue. The only point is the last element will point to the first element, which make is the ring buffer. Okay, one of the benefit of the circular queue that we can make use of the space in the front of the queue. This is what I have explained. In the normal queue, once the queue becomes full, we cannot insert the next element even if there is a space in the front of the queue. This is whatever I have explained. This is written here. Now, what we have to write? We have to implement my circular class, which will have it initialize the object to the size of the queue k. Okay, and then the front and the rear and the enQueue, deQueue, these are the things that we have to implement it. So now it's time to let's generate a class. Okay, so this is what they write a function, but I will write a class here. Okay, so I will say class my circular queue, and in this class, first of all, I will create the constructor function. So this constructor function, in this constructor function, I will get the k. I will get the k, that is the capacity. Okay, so I will say this dot capacity, like how many items you can add. This is the k, and then for the normal queue, I will say this dot head, which is pointing to null. This dot tail, which is also pointing to null. And one more thing, I will say like what is the current size, that is this of 0. Now for adding the circular, like using the linked list, I need to add a new one more class, that is node. So class node, which will have another constructor function, and that will take the data, and I will say this dot data equals to data, and this dot next initially we will pointing to null. Cool. Now here we have to write few more classes, like few more functions. So when it will be full, when this dot size equals to this dot capacity, that means it's full. And what is the condition of is empty? So here I will say is empty means this dot size equals to 0. Okay, this dot size equals to 0. Then what is the rear? So in the rear I will say return this dot is empty. If it is empty, then what you will do? You will return here return the -1. Okay, you have to return the -1. Otherwise you will return this dot rear means tail dot data. Similarly at the front you will say the return this dot is empty, and if it is empty, in that case you have to return the -1. Otherwise you will return this dot front, that is head dot data. That's a simple helper function, and that will work perfectly fine. We will check it later on. Now we have to make our enQueue. So in the enQueue, what is the first step? The first step is to check if it is full, then you can't add. Okay, so you will say this dot is full. If it is full, then you will return false. Return false. Otherwise, what you will do? You will create new node that is a new node using the class, and here I will pass the value we received. Now what we will do? If it is empty. Now let's understand how to implement it. Let's say this is our list, or you can say our queue, and in this queue our head is pointing to this and our tail is pointing to this. Cool. Now to make this a circular queue, what we have to do? We have to make this 3 should pointing to 1. Okay. So what is our first operation? So before first operation, let's understand what is our initial position. So initially our head will pointing to null, and our tail is also pointing to null. Now if you want to add first item, so we are discussing enQueue operation. For enQueue, you have to add the item. So what you will do? You will first of all generate the item, let's say 1. Initially, because there is no other item, so your head will point to 1, like this, and tail will also contains to 1. This is what you have to do. One more thing that you have to do, that this tail and should points to 1 only. So its nest, one nest should points to 1. The second case, if let's say you have 2 items. So in this step, this head is pointing to this and tail is pointing to. Now what you have to do, if you have to add 3. So what is the first step? The first step is this tail nest is pointing to 1 right now. Right? So what you will do, first of all you will break this and you will make this 2 pointing to 2 will points to 3. This is the first step, that 2 will points to 3. Second and the third step is this 3 will points to 1. So 1 is pointing to 2, 2 is pointing to 3, 3 is pointing to 1. And the last thing that you have to do, that now our tail is this. Now our tail is this. So this is what we have to do. I hope you understand. If not understand, let me just write the code for this and then you will be able to understand it. This is the code that we have used to add an item in the queue. Now we will use this same code for the circular queue. Just we will go here and paste this code. So now here if you say, if it is empty, so this the head will point to null and this head is pointing to the new node. And if it is not empty, you will make the nest point to the new node. Now this is perfectly fine. The only thing that we have to do here is return true. Is that work? Is that work? No, there is one more thing that you have to do. In the queue and the circular queue, the only difference is the last point should point to the first item. So how you will do? After adding the item in the queue, you have to make this dot tail dot next. So the last item, that this dot tail is the last item, its next should be points to this dot head. Just one line of code and your queue becomes circular queue. Yes, this is what it is. Now let's understand how to implement dequeue operation. So there will be 3 cases. The first case is very simple. Let's say if you don't have any item, how you will delete it? You can't delete it. You will just return null. So case 0 will be if there is no item. Case 1 will be if there is a single item. If there is a single item. So let's say this is a single item. Head is pointing to this. Tail is also pointing to this. And its nest is also pointing to this itself. So in that case, what you will do? Simply, if there is no item, your head is pointing to null and tail is pointing to null. So this is what you have to do. If there is a single item, make your head and tail points to null. And how to check if it is a single item or not? You can show this dot size equals to 1, or you can show your head equals to tail. Cool. The third test case, which is our main case, will be how you will lead in this case 1, 2, 3. So in this case, what I will do, I will make my head points to this. If I make this, will it work? No. We have to do one more thing. We have to make this tail nest should points to 2. This should also points to this. So the step 1, our head points to head nest. Step 2, our tail points to tail nest. Okay. So now our list will be 2, 3 like this. So let's implement it. Case 1, that is if our this dot empty is empty. So in that case, you will return null or return false. Let me check. Return false. Okay. So return false if the operation is not successful. Otherwise, what we will do, we will delete. But before deleting, we have to check if this dot head equals to this dot tail. That means you have only one item. In that case, what you have to do, make your head points to null and make your tail points to null. One more thing, this dot size minus and return true, that you have successfully deleted the item. But if this is not the case, in that case what you will do, otherwise you will make this dot head points to this dot head dot nest. And one more thing that you have to do, the last step is this dot tail dot nest should points to this dot head. So this dot tail dot nest will points to the new head. This is what I think this should work perfectly fine, but let me just try to run this code and let me make this, because now they are not working like that. So yes, it is working perfectly fine. If I submit it, will this work? Will this work? Work? Okay, it's getting accepted. So this is it for this video. We have understand what is queue using an array, linked list, stack, and we understand the circular queues too. So in the next video, we will understand about the binary tree, and that is where you are going to use the stack and queue. Although I have shared all the source code and some practice question on the stack and queue on the GitHub repo, But the main thing, the stack enQueue you are going to use in the binary tree video. So this is it for this video. Make sure to hit the like and subscribe button and do share this video with your friends and do give a shout out on LinkedIn. This is it for this video. Thank you.